All right, hello everyone. We are going into our discussion today on dividing by a monomial. So we've looked at multiplying polynomials by a monomial. So now it's kind of that inverse. What would happen if we had we're given a polynomial and asked to divide, okay? So we still need to think of that area model. We still need to think of if we know the area of a rectangle and know one side, what is it going to look like, and try to get what is it going to look like to try and get the missing side. So, I mean, if you think of this in really simplistic terms, if you had a rectangle with the area of, let's say, I don't know, 72, okay, centimeters squared, and you knew that this side was 6 centimeters squared, how are you going to find this side? Okay, so you would do 72 divided by 6 equals 12 centimeters. Okay, sorry, that shouldn't have been centimeters squared. The side length shouldn't have been centimeters squared. But it would be just 12 centimeters. Okay, so what we're doing is we're taking that area that we know, or we're taking this area that we know, we're taking this side that we know, and we're dividing them. Okay, so the same thing can kind of be done with any type of monomial as well. It's just now we got to think about how does it affect the variables, the exponents, and those types of things. And so we're going to pull back in some of our stuff around, or some of our knowledge around exponent laws as well. But just thinking of this 6x divided by 3, okay? We have seen that before where we're doing 6x divided by 3. What we would do is we consider that maybe 6 times x divided by 3 times 1 or something like that, okay? And then we're going to reduce these two down to get to x, right? We kind of know this by this point that we're just looking at the coefficients in this one, or the numbers. We're not looking at the variable with that, okay? So we're taking that knowledge and we're using it. One of the ways it can be modeled, just erase that last little bit over here, is that we can model it, and this is directly from your textbook, okay? We can then look at it and model it. We have 6 x's here, okay? So we have 1, it's really small, but 2, 3, 4, 5, 6, okay? That's would be like if we had some rectangles. You know what? I'm just going to draw that and make it a little bit bigger. So this is kind of the same idea. Imagine these are my algebra tiles. They're all the same size. I'm a perfect drawer, and they're all the same size, right? So this is x and that's x, okay? I've divided them into 1, 2, 3 rows. So I have 6x in here. I have 1, 2, 3, 4, 5, 6, okay? We know that this is 6, or sorry, that those equal up to 3, okay? If we consider each one of those 1, we know that those equal 3 altogether. And this altogether equals 2x. That's one way you might see it modeled, okay? This idea is pretty simple. We know that 6x divided by 3 equals 2x, okay? We can model it this way too. Here, this second rectangle, this was really close to what I did up there with the 72, or I did a minute ago with 72 centimeters squared as my whole area, right? And I said 6 centimeters on this side, right? You're taking this 6x, you're dividing it by 3, and you're getting 2x as your answer, okay? So dividing is, as we know, creating equal groups. So if you're given a polynomial, you can try and think about how you might create equal groups. Okay, so solve the following equation using algebra tiles and creating equal groups. This is our example. So it says 4s squared minus 8 into 4 equal groups. So, I mean, if we're going to draw this, one of the things to think about, I'll try to make it a little bit bigger, is we need to make that into equal groups. How do we do that? So I'm actually going to go and I'm going to draw 1. So that's an s squared, 2, 3, 4, right? I have 1, 2, 3, 4. And then if I were to put 2 negatives with each one of those, I get my equal groups, right? I could circle one just to kind of make it a little bit more apparent. I can circle them, right? I'm creating equal groups. So I have 4 equal groups that in each group I have s squared minus 2. Okay? So you can also think of that if I were to take the whole equation for s squared minus 8. What did I do? Well, I actually divided each of these terms. I'm going to circle them. I divided them each individually by 2, or by 4, because 4s squared divided by 4, and then if I considered it 8 minus 8 divided by 4, okay, well, what happens? We know, even though I hate this term, that these two cancel out. Hate that term. We know actually that they equal 1. Okay, so then I'm left with s squared, and 8 divided by 4 leaves me with 2. So I've got the same thing. If I'm doing that numerically, I now have the same thing. Okay, we can draw it like this. You might see it asked like this. This is actually right from your book. I just chose to draw it rather than just grab the clip. But the thing about this is, and you'll see this here hopefully in your notes, that this is, we can only model it this way if there's no variable in the divisor, okay, or in the denominator. It wouldn't work if we had something like, I don't even know, 3x squared plus 6x divided by 3x, okay? It wouldn't work. We couldn't draw it the same way. So then how do we draw that? So this is kind of where we get into that other piece of how would we draw that. It's going to come in a second, okay? You'll see it, what I mean, in a moment. So we can also think about this kind of in terms of what we did with multiplying a little bit, okay? Where we're going to create some sort of rectangle, okay? I like this idea of an open table, okay? So what I'm going to do is I'm going to draw this, the numerator, or my dividend, inside here, okay, inside this portion here, okay, because that's kind of where the product goes. We have to multiply something here by something here to get whatever we get in the middle, okay. So I'm going to put the 2x plus 4. I'm going to, if I divide them by 2, I'm going to put 2 little algebra tiles here, okay? And then I'm going to try and line those up equally in rows here, okay? So then I get this, 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 and that. So I have in here 2x plus 4, and here I have 2. Now I have to figure out what goes here. And this is the thing, is that this piece here, okay, indicates what goes there. So if I were to take this and redraw it there, okay, my quotient becomes x plus 2. All right, and if you think about that, just think about it for a second. If I gave you the multiplication 2 x plus 2, 2 times x plus 2, and we multiplied that out, we would get 2x plus 4, okay? So that is right. That's how we verify that. So we need to remember that we can create this kind of grid. Okay, this is also that area, the idea of the area model. All right, so realistically, again, if we look up here in the steps, okay, so we want to think about all of this when we're drawing it, okay, and it's gonna get trickier when it's a negative, but that's okay. We want to see that. So what you're going to do here symbolically, okay, is a little bit different. We know that the answer to this is going to equal x plus 2, okay? That's what we know. Now, to do that symbolically, we have to ensure, I'll scroll down here a little bit. We have to ensure that every term is divided by the monomial. That means that if I have a trinomial on top, okay, so just look down at the below. Let's say I have 4x squared plus 8 9x plus 16, just for fun, and I divided that all by 4. I'm going to divide 4x squared. That's going to get divided by 4 by itself. Okay, 8x will be divided by 4. And then we're also going to divide 16 by 4. Okay, we have to divide each and every term. All right. So we have to divide each term in the trinomial, or the dividend, I guess, or whether it's a or binomial or a trinomial or even a polynomial with more than 3 terms. We have to divide every single term by the monomial, which is in the divisor. So every term inside the bracket is divided by the divisor. This is referred to as distribution. Okay, so remember that coefficients divide coefficients and variables divide by variables. Okay, remember also the exponent law for dividing exponents of the same base. So if I had am divided by an, it's really what we're doing is we're subtracting m minus n. Okay, so x over x, it's going to equal 1. 6x over 2x, okay? That's really small. I'm going to make it a little bit bigger. 6x over 2x, okay? So if we treat those separately, imagine you're dividing the 6 and the 2 together and the x together, okay? So 6 divided by 2 leaves me with 3, and x divided by x leaves me with 1, so I don't have to do anything there, okay? This one, x squared divided by x squared, technically, you're going to go x squared minus 2, 2 minus 2, which gives you x to the 0, but it also equals 1. We know that, okay? So this is going to equal 1, and then we have 5x squared divided by x. I can't divide the coefficient 5 by anything because there's no other coefficient, so I'm just going to go x squared divided by x, okay? And if you think about that, I have x squared, so it's x times x. That looks really hard to see. X times x, okay, I have 5 times x over x. Well, these two of these x's are going to equal 1, so what I'm left with is 5x. Okay, so if we're considering it in the terms of fractions and things like that, we can use some of that knowledge that we have from fractions to continue to divide. All right. So we've got some more examples. I am going to try and show you maybe with a couple of them how we could draw them. I'm going to show you this first one, how we might be able to draw it, okay? So it's going to, with that idea of a rectangle, hopefully I can get it big enough. All right, so I'm going to start with that area model that I showed you, okay? So again, it's going to look funny because it's 14x squared minus 21x, okay? So it's going to look really, really tough. You know what? Let's ignore that for a second. Let's do, what could we do? 6, no, that's way too many. Let's do 2x squared plus 4, yeah, plus 4x divided by 2. Let's keep it simple, okay? So I am going, actually no, let's divide it by x. Let's do that. Let's divide it by 2x, okay? So I am going to draw my 2x squared, or actually, sorry, I'm going to draw my 2x's. This time I'm actually going to draw them vertical, like this, okay? So I'm doing this equation up there. If you want to do that on a side piece farther over, just so you have it, so you can have that example. And then in the middle here, I'm going to draw my dividend. Okay, so I have 2x squared. Remember, I'm going to try and keep this in line. Oh, let's throw in a negative there. Let's go back and change that just a tiny little bit. We're going to make that negative 4x. Okay, and then I'm going to do my 4x's, still vertical, color them in a little bit. Okay, and then do that and do that. Okay, so if I think of this, I have an x here and I have an x squared. Well, in order to do that, I need another x here. So I'm going to go x times x to get this x squared. Okay, and so here I have an x and here I have a negative x. Well, X times what is going to give me negative x? Well, x times negative 1 is going to give me negative x. Okay, so I actually need 2 of those, right? So this has become my quotient. That's my quotient up there on the top, okay? And if you think about that, that kind of looks like the division symbol that we're so used to, right? 2x squared minus 4x. And what I'm left with is x minus 2. That kind of, if you remember that we want it to kind of look like that long division symbol, right? That is not a bad thing that if you remember it that way. So that's x minus 2. All right. So that's one way to do it symbolically. There's lots of different ways, but that's kind of the best way to do it symbolically, or sorry, by modeling it. Symbolically, we're talking about doing it with numbers, okay? So I'm going to leave that drawing there. But here, if we come back here to the one that's actually in your notes, okay, you're going to have 14x squared minus 21x divided by 7x. Remember, we have to divide both of the terms in the dividend by the divisor. So really, what I'm doing is I'm doing 14x squared divided by 7x minus 21x divided by 7x. And I would strongly suggest that you write it out like that you write both. Okay, just at least for the first little bit till you get really, really used to it. That just looked messy, so I'm going to fix it up here. 14x squared divided by 7x minus 21 divided by 7x. Okay, so now if I think about this, I'm going to divide the two coefficients. So 14 divided by 7 is 2, and x squared divided by x is going to leave me with x. And then I have minus 21x divided by 7x. So 21 divided by 7 is 3, and x divided by x is going to leave me with 1, right? So my quotient becomes 2x minus 3. Okay, my simplified version of the polynomial of that division equals 2x minus 3. I'll do one more example, and then I'm going to ask you to pause it on your own so that you can do the next 3. Okay. All right, I'm not going to draw this one. We're just going to consider it as it is, okay? So again, we have negative 3m squared plus 15mn minus 21n squared, all divided by negative 3. So I'm going to write this out. 3m squared divided by 3 plus 15mn, or sorry, divided by negative 3 minus, 21n squared divided by negative 3. All right. So if I take and consider this term on its own, I'm going to look at that one and I'm going to say, okay, I have negative 3m squared divided by negative 3. Well, negative 3 divided by negative 3 gives me 1, so I'm left with just m squared. Okay, then I'm going to add my addition symbol, and then I'm going to consider the next term. And I have 15mn divided by negative 3. Well, 15 divided by negative 3 gives me negative 5, and then I have the mn left over. Okay, so I have plus negative 5mn, and then I'm going to consider this term. 21n squared divided by negative 3. Well, 21 divided by negative 3 gives me negative 7. So I'm going to write my subtraction symbol, and then negative 7n squared. Now, you might say, well, Mr. McKenzie, can we change that around and simplify it? Absolutely. So I have a plus and negative 5mn. Okay, so I have m squared minus 5mn, and I have subtract negative 7n squared, so plus 7n squared. I can change that. You can also consider the terms independently, okay? If you had a thought of it, I'll get a different color here, of positive 15mn divided by negative 3, and then a negative 21n squared divided by negative 3, then you would have gotten right to this. Okay, both are acceptable. I would accept both answers myself, but remember, if you had a multiple choice where this was a possibility, that is a correct answer as well. Okay, pause the video, take a couple minutes to do this on your own, do the next 3 on your own, and then restart the video. Okay, so Again, I'm going to show you kind of step by step. Okay, so reminder, we're going to take and we're going to go 6xy divided by 3y plus 15y, oops, make it an x, 15y squared divided by 3y. Can only divide coefficients by coefficients and variables by variables. So 6 divided by 3 gives me 2. Now, there's no x in my divisors, so the x is just going to stay there. It's just going to remain. And then y divided by y, well, that's going to give me 1. So those equal 1, so I'm just left with 2x, okay? And then I have 15y squared divided by 3y, okay? So what happens is I'm left with 5y. 15 divided by 3 is 5. Y squared divided by y is, if I go y2 minus 1, remember that is an exponent 1, I get y to the power of 1. Okay, so that's how I get there. You might say, well, Mr. McKenzie, how do I double check my answer? Okay, well, go back, use your divisor, and multiply it by the 2x plus 5y, your quotient. Okay, so if I go 3y times 2x and 3y times 5, I get 6xy plus 15y squared. Yes, I did it right. All right, let's look at the next one. Again, we got to watch we got negatives now, so we got to watch those. Okay, so I'm going to write this out, 14x squared divided by negative 4 minus 6x divided by negative 4 plus 12 divided by negative 4. Okay, so 14x squared divided by negative 4. Well, 14 divided by 4 is going to give me a decimal number. Again, totally fine. We're going to get negative 3.5 x squared. Okay, we have negative 6x divided by negative 4. Well, negative and negative give me a positive, so plus 6 divided by 4 is 1.5 x, and positive 12 divided by negative 4, I get negative 3. And finally, the last one. Okay, 4x squared divided by negative 2x minus 6x divided by negative 2x. Okay, my negative's not very clear here. So, I have 4x squared divided by negative 2x. Well, 4 divided by negative 2 gives me negative 2. X squared divided by x leaves me with x. And I have negative 6x divided by negative 2x. Well, negative divided by negative gives me a positive 3. And x divided by x would give me 1. So I'm just left with negative 2x plus 3. So pretty simple, not super complicated. All right, let's put it into context a little bip with one last question, and then I'm going to show you one final thing as well. So this is context question, okay? We have area, determine the width of the rectangle shown. So we have an area of 8x plus 20x squared and a length of 4x. So the area becomes my numerator or my dividend, 20x squared, and I'm dividing the whole thing by the length. Because remember, area is just base times height. So if I have area is 8x plus 20x squared equals 4x times the height, I'm going to divide both sides by 4x, right? This is that basic algebra that we know. And you see here, what I've done is I've created the same equation I have there, okay? So I'm not going to rewrite it this time. I'm just going to go 8x divided by 4x. Well, 8 divided by 4 is 2. X divided by x is 1. Gives me 1, right? Leaves me with x to the power of 0, which is equal to 1. So I'm left with 2. 20x squared divided by 4x. So I'm still in the positive. 20 divided by 4 is 5. And x squared divided by x is x, right? Because x 2 minus 1 equals x to the power of 1. Okay, or if you want to think of it this way, we have 20x times x over 4x, right? So these two x's we can cross out. 20 divided by 4 leaves me with 5, and I have this x remaining, so I get 5x. Okay, so the width is equal to 2 plus 5x. Putting it into a little bit of context for you. Okay, not that challenging. We know how to find the width of a rectangle given its area and its base. This time we're just using variables and we don't know what the value of that variable is. All right, just kind of a last thing. Um, Not necessarily something we're going to get into this year, but I just want to give you an idea. Okay, dividing a polynomial and having a remainder is also possible, but not something we go too deep into grade 9. As with dividing a polynomial regularly, you want to split it into separate fractions, and you may simply have a fraction you cannot simplify. So if I take this one and I kind of split them all up into those fractions that I had before, right? So 2x squared divided by x plus 5x divided by x minus 6 divided by x, okay? So I can simplify the first two. I have 2x squared divided by x. Well, that leaves me with 2x plus 5x squared divided by x. Well, that leaves me with 5. But I can't simplify this one. So all I'm going to do is write it as the fraction. And that's it. I've taken part of that, I've divided it, but I leave the rest as a fraction. Okay? I'm dividing each term in this trinomial by that number. Okay? And even if you think about that, scroll up a little bit here. If I were to take and I were to multiply x, let's change colors, x times 2x plus 5 minus 6 over x, right? And I would have 2x times x. I'm going to multiply each term. Okay, I'm going to distribute it. Plus 5 times x minus 6 over x times by x. Okay, so I have 2x times x would leave me with 2x squared plus 5x. And just like we've seen when we've done algebra in the past, this minus 6 over x times by x, well, these two are going to equal 1. So I'm left with negative 6. Okay? So I was able to reverse that, but you can have this remainder here. Okay? So that's kind of it. It's actually a lot easier than thinking about multiplying because it's just the inverse. It doesn't change a whole lot. So make sure that if you got any questions, you ask them next class. But thanks for watching, and I hope this made some sense.